This area is basically belonging to the Mingora ophiolitic melange. So it's belonging to the Mingora ophiolitic melange, and this is representing the area where the Indian plate has collided with the Pakistan iron ore. Because of that intense collision, the rocks of oceanic lithosphere as well as the Indian plate rocks, which are metasediments, Alpuri group, they were jumbled together. And the ophiolitic sequence, because of that instant tectonic activity, the ophiolitic sequence was also dismembered. It was broken into pieces, right? And that is why we call it melange. Melange is basically a chaotic mixture of igneous rocks, here the oceanic lithosphere rocks, and the sedimentary rocks or the metasedimentary rocks, which are derived from the ophiolitic units, and they are formed when there is intense tectonic activity or collisional activities, right? So this is marking the collisional boundary. If we go towards the east side, we can encounter another ophiolitic melange, कि जहाँ पे आपको ocean lithosphere का uppermost portion, जिसको क्या कहते हैं, ultramafic rocks, उसके साथ आपको gabbroic rocks, उसके ऊपर फिर sheeted dikes, और उसके साथ again pillow basalts which have been metamorphosed to green schist or the blue schist facies, and on top there could be some plagio-granites and metasediments as well. Okay, within the metasediment we can encounter the manganese. Further moving towards the west, we encounter another ophiolitic zone, which is called the Dargais Khakot ophiolitic melange, right? And further west, the northwest में बाजोड़, नवागई बाजोड़ ophiolitic melange encounter होता है, ठीक है? Similarly, the Prangar ophiolitic melange is again in Moman agency, and then that collisional boundary, which is known as Indus suture zone. What is the name of this collision? The collisional boundary between the KA and the Indian plate is called Indus suture zone. And along that suture zone, different ophiolites have been discovered and they have been reported, and I have mentioned all of them. Okay? Within this Mingora ophiolitic melange, we have one of the best emerald deposits of the world. Their deep green color and their transparency and their relatively unfractured nature make these gemstones one of the most appealing gems of the world. Now, the reason for its green coloration, there could be two possibilities. It could be because of the chromium, or it could be because of the vanadium or manganese and or iron. People have worked on it, and Rafiq and John 1985, they have analyzed these gems, these emeralds, and they have found that chromium is basically the cause of the coloration to the gem. So it's chromium is the major reason for the coloration of this gemstone. Okay? Actually, how did it form? It's a secondary mineralization along this suture zone. And how did it form? You know, what is the formula of the emerald? Yes, beryllium aluminosilicate. ठीक है ना? So we need two components, beryllium and the coloring agent, which could be chromium, vanadium, iron, like that. These rocks are hosted within So what are the hosts for these rocks? These gemstones, these emeralds are hosted within the carbonate rocks. And they can be named as talc carbonate schist, talc magnesite schist, and there could be talc quartz schist. And these rocks जो मैंने mention किए, talc quartz schist, talc carbonate schist, talc magnesite schist, this is basically that talcose rock, which is talc magnesite schist. You can see that this white coloration is reflective of the fact that it has abundance of talc. So they are found, they are hosted within these talc carbonate rocks. What are the protoliths for these talc carbonate rocks? They were actually ultramafic rocks. And the alteration of ultramafic rocks, ये कोई पेरिडोटाइट थे या डानाइट थे या हस्बरगाइट्स थी, उनकी मेटासोमैटिक मेटामॉर्फिज्म हुई और उस वजह से टाल्क बना. ठीक है? So the chromium and the emerald came from this ultramafic rock. So we know that ultramafic rocks के अंदर chromite की deposits भी होते हैं. तो इन्हीं sequence के अंदर at different places, particularly at Dargai region, at Mohmand region, at Bajor region, at Shangla region, we have economical grade chromite deposits. And the chromite deposits are basically magmatic deposits. They are primary mineralization. Got my point? Yes. So this ophiolitic sequence is having primary mineralization in the form of chromite mineralization, which are again hosted in peridotites and these danites. So these talc carbonate rocks, these magnesite rich rocks, are the result of the alteration of those ultramafic rocks. Okay? So the emerald mineralization took place when, due to collision, the chromium was reactivated from these ultramafic rocks, and beryllium was either derived from the post-collisional magmatism, like it might have been derived from the Malaccan granites, it might have been derived from the ignimbrite rocks in the Peshawar basin, which are again 27 million years old, and it could be some hidden magmatic activity, or it could have some other source, because ये जो emerald mineralization है, it has been reported from Bajor, Nawagai ophiolitic complex. It has been reported as well from Bucha area, Plangar ophiolitic complex, and the same emerald mineralization has taken place in Charbagh region. अब यहाँ पे तो ये Malaccan granites के नज़दीक है. But what about the Charbagh, which are several kilometers away from here, and the same could be applied to the Bucha and the Bajor region. So it could be, and there could be some other alternative, that because of that collision between the Indian plate and the KA, the Indian plate is getting subducted slowly. So because of that subduction activity, there could be some hydrothermal mineralization. There could be the formation of some hydrothermal mineralization. In these hydrothermal mineralization containing beryllium, okay, provided the beryllium source to form the emerald mineralization in the earth. Okay? So that's actually the summary of the host rocks there and the mineralization in the